Hello and welcome to the first Platform Extensions breakout session. My name is Gordon Smith, and today I'll be monitoring the session chat for any questions and comments you may have, so please be vocal. Starting us off today is David de Hilster, who is going to talk about natural language processing, visual text, and the upcoming NLP ECL plugin. I know he has a lot of great content, so without any further ado, I hand you over to David.
Thank you very much, Gordon, for that introduction. And yes, today I'm going to be talking about some exciting new plugin we're going to be launching for NLP++, ECL, and that's the NLP++ ECL plugin. Of course, we know the enterprise computing language is a powerful computing language for supercomputers, and it has modules and bundles and plugins, including the machine learning visualization bundle, databases, and of course plugins. And the plugins themselves are quite a few of them. And today I'm going to be talking about the NLP++ plugin. So just a few bits on terminology. Natural language processing is what the full, for the abbreviation NLP is natural language processing. It's the use of computer programs to understand and process unstructured language or text. This is different from speech recognition. A lot of people will get that mixed up. Unstructured text can be full text, prose, documents, articles, written language, OCR, and messy text, text from PDF to text conversions, marked up text. But today, again, we're going to be talking about processing text. A quicker overview before I get into a real live example here is NLP++ is a computer language for natural language, and we'll be talking a lot about that after the example. And NLP++ encodes human reading knowledge that can be used for data extraction from unstructured text. And NLP++ plugin, the plugin allows users to call NLP++ analyzers in ECL. So the first thing I'm going to do is do a comparison with ECL without the NLP++ plugin, because it does have some nice functions for NLP, and then versus ECL with the plugin. And we're going to look at this area, which is an interesting area, indictments that are buried in full text articles. Important information exists in Department of Justice articles that is from public press releases about people who have been indicted for crimes. And how do we extract this information from full text in press releases? So let's take a look at how you can do it today out of the box with ECL patterns and rules. Here's article 1. We're going to take a look at it. And what you see in yellow here is you can see some pretty regular patterns. You have a name followed by an age, name followed by an age. And then at the second example at the bottom, Daniel, you'll see a name followed by age and where they live. And what you have available to you today in ECL are patterns and rules. And these are the assumptions that you can make. This is actually a person who wrote these and gave them to me, one of the analysts at our company. And these are some of the assumptions. People's names are capitalized. People's ages and addresses often follow in a predictable pattern. And in the DOJ indictment articles, ages and addresses are often given to those accused or who are indicted. ECL, you can write patterns. So here's some words and numbers and initials. You can see it's pretty simple. You can I don't need to explain too much there. You can see here, so you can put also vocabulary into patterns. Here you see state abbreviations and the entire state names. And then you can write rules. Again, this is all in ECL today. You can do this and run this. And you can see here a person was writing rules for first initial, last, first name, names, and then the bigger proper nouns where they have 3, 4, 5, and 6 capitalized words together. Now, if you run it on that article that we saw, this is the exact output. In fact, I used our playground, which is available to everybody for ECL, and I ran it there, and this is the output. In fact, you can see you get the names and the ages, and also at the bottom you get not only the names and the age, but you also get the address of the person, where that person is from. But we do have a problem, who is guilty, and that's very important. You don't want to get that wrong. So ECL patterns and rules cannot identify cannot confidently link a name-age pattern to an indictment or guilty verdict. Right now, we're just looking at that one pattern. It assumes that anyone mentioned in the article with a name, age, or address is the accused, and many articles do not have the name, age, address patterns, meaning indictments and convictions can actually be missed. So let's take a look at ECL with the new NLP Plus plugin and developing an NLP Plus analyzer. We're going to take a look at a different article. This is the first article we looked at. That's pretty easy. You don't need NLP for that. So let's take a look at another article, which is a lot harder. As you can see here, this is an indictment where you see the in highlights St. Louis resident, his role, and the name in the second, Babatunde in the second paragraph. Well, how do you deal with this? This is called a NAFRA. And NAFRA is the fancy word for us linguists for words referring to or replacing a word in the text, often to avoid repetition. Obviously, when you write these articles, you don't want to put the person's full name every time. You want to use he, she, their, resident, the accused. So we're going to take a look at this article with the NAFRA, and you can see that St. Louis resident is referring to, in this case, Babatunde Taiwo. And in fact, his role is Babatunde Taiwo is also referring to the same guy. Now, it turns out that I know it's a male because it's his role. And I know this person lives in St. Louis because I can read as a human and figure this out. But how do we program that? Obviously, with just the rules and patterns, that's very difficult, if not impossible. So we know this, let's just examine it like human beings who read, right? We know there's an indictment in that first sentence, and we know that there's another indictment talking about the same indictment in the second sentence. The second sentence gives us more details about that indictment. In fact, one of the things we can look at is the linguistic assumptions for articles. The first paragraph is often a summary and often uses a NAFRA. Following paragraphs includes specifics, including names, and we linguistically know how indictments and sentencings and punishments and phrases are constructed in English. We can use these assumptions in creating a linguistic analysis of this text. So NLP++, as I said before, allows us to encode what humans do. And because it's a programming language and you must write the program, this is how I went about solving this problem. First, me as a human, and then we're going to show how we program that in. Well, first, we don't read everything. We skim the sentences, we find interesting data, we find names and match them by references. So if we have Taiwo around the article, we know that's referring to the full name. We find titles and locations and crimes and punishments. We relate all of those things to interesting events, and we use those events to resolve pronouns or other anaphora, so that when they mention like just a partial name, we will have to go back and find that real name so we can get that information, solid information. And we must remember, okay, this is my David D. Hilster's solution. Each programmer will come up with their own solution and implementation like all computer coding. It is not automatic, it must be programmed, but there's a lot of advantages to that. Okay, so first of all, we have a knowledge base in NLP++. We can create a knowledge base for different phrasings of indictments. Now, this sounds very intimidating, but it's not that hard, actually. We can keep track of sentences, and we keep track of names and locations and crimes. So this is one of the advantages of using NLP++. And here are some actual knowledge-based shots from our IDE, the VisualText IDE. And you can see this is for articles and sentences and things. We use it as bookkeeping. As we're processing, we're going to keep things in that. NLP++, the computer language, allows you to do that. I'm going to show you how you do that. People and names, keep track of those. Also, locations and crimes, keeping track of those. You have St. Louis, you notice in the first sentence, didn't say what state is. Well, later on in the text, we knew it's from Missouri in this case. Now, encoding, how do we encode the indictment phrasing? How we say that in English? Well, we take a look at this sentence, this first sentence. Basically, you have someone returned an indictment against someone. You see those things in green. This is one of the ways we can phrase an indictment phrase. So I put this into the knowledge base. I can design this. So I'm putting knowledge into the knowledge base. You can think of the knowledge base basically as a directory on a computer, and those are folders. That's the easiest way to think of that. So you can see I have an indictment, and I have underneath the indictment, under the, alleges, attempted, against, and these are all different phrasings of indictments. There's more below. And so I called this one against because, again, that seems to be a key. So how did I put the knowledge into the knowledge base? Well, what I did is each of the folders in the knowledge base, again, like a folder or a file in a directory, you can put attributes to it or properties. So I said, look before it and look for an agent. The underscore is sort of like an object, not the word itself. And if you do find it, you're going to call it the accuser. Then I've got underneath my knowledge, I put under the attributes for against, and I say look after it to find the agent. And if you do find that, and the match is required for this type of phrasing, if it doesn't have against, it doesn't match this particular phrasing. Then if you do find that, that's the accused. And if you have a role, which can be almost anywhere, you look for the word role, and it says, you see there, right here, you look for before and look for the possessive. Okay, so I'm going to take a look at the second sentence. We're going to do the same thing. This is different phrasing. In fact, you have an indictment charges someone with crimes. That's the basic pattern. You notice then we had the against. Now I'm going to do one for indictment, what I call charged with. And here you can see charge. It's a verb. What comes before it would be the accuser. What comes after it would be the accused. Those who are linguists, yes, it does know the difference between passive and active sentences. Again, I programmed this all in. This wasn't out of the box. I just programmed it. And here, if we find the with, we look after to find any of the crimes. We can easily match those and gather them up. So we have that information. So now we must use that knowledge that's in the knowledge base that I created. Well, we have rules in NLP++, just like the rules you have in ECL that match patterns for dates and names and locations, et cetera. And we also have functions you can write that can traverse the parse tree, the structural tree of the sentence or the article, and the knowledge base to process it further. So let's take a look at anatomy of one of the pattern matching rules. This is NLP++. Basically, you have here a sentence, Netflix stock is up 200% from $100 to $300. This is just one. This is not for this particular one, but it's a good illustration. All of these things must be matched, 1 through 9. Or sometimes you can have optional, and it rewrites and puts these under a tree, like diagramming a sentence under the event. Once you're down, what's really powerful about NLP++, when you match an event, you can do whatever you want. In this case, I'm going to make a concept in our knowledge base called the stock. I'm going to take the fourth element, call it an action, the fifth element, call it percent, the seventh, call it from and to. And that builds knowledge, meaning, and then you can also build a tree. And a very important part of this too, I'm building 2 prototypes within the company right now. It's very important because we don't want to look at everything. People will skim a text. I have some documents where we only look 5% of text. So you can say this particular rule will only fire under this context. Syntactic trees are automatically a part of NLP++. This is a full parser. It's not from the this particular analyzer I'm using. And you can see, if you don't know what a parse tree is with noun phrases and verb phrases and adjectives and determiners, those of you who are old enough, you may have diagram sentences. So that's a way to imagine. This is automatic for you, and you can build these up in any way you want. Now let's take a look at this problem that we were looking at before, the DOJ articles. And this one's very simple. I'm going to say, go to each sentence in the paragraph and go see I'm going to write a function that calls collect event. Does this sentence have those prerequisites that we have in the knowledge base? So that's how that's done. Now I write a function. This is an actual function in NLP++. It's called collect event. You hand it the sentence node, and you can, we're going down in the domain. So we're looking down, we're going to look through the domain, and we're going to build an event here and find the anchors. It's not important that you understand. I'm not here to show you that. I wanted to show you actual NLP++ code, because you can write functions to work mess around with the syntactic trees and also the knowledge base. So this is how we do it. I wrote a function, the function collect event, which we see down here. And so if you're going through, you're going to find the anchor you can see down here. So you're looking through the text in the first sentence and you found the anchor. Well, once you find the anchor, this function is going to go searching backwards, finds a comma, searching backwards, finds a location sitting in St. Louis, searching backwards in the sentence, and it finds a federal grand jury, finds a match, says it finds the accuser, and gets it. So let's take the second one. The against, we're going to find the word against. This time it's searching forward, searches forward, finds the determiner of the word A, then finds the resident, says, okay, that's an agent, that's something that can do something. I've matched that, good. Let's go on. And we are looking for role now. It finds the word role, it searched backwards and immediately finds his, and we find, in fact, the role, and that's good. So what do? Well, because it's NLP++, in that function, I'm going to create an indictment event. I'm going to, as many indictment sentences I find. It may be, I think in this one, we only found two indictments in the whole article. And you can see here, we have the federal grand jury as the accuser, St. Louis resident as the accused, and we have his. We have no information about who he is, but we hoping we can find it. And we found it, of course, in the second sentence, doing the same kind of thing. So I'm not going to go through that. Same process, same function, and it finds the accused, Babatunde Taiwo, and all the crimes that are associated with that person. So I wrote a second function called resolve an affirm, which will go through this knowledge base. And it says, oh, by the way, if I find something that we call an anaphoric reference, and that is the resident, which is not attached to anything right now, I find that, oh, it's in the accused. So maybe if I go to the second one, oh, there's the indictment, there's an accused, and I find out, and I know by my pattern matching things that I did before, that this is a full name. By the way, just to remind it, just to tell everybody, we have no dictionaries for names, none whatsoever. The only dictionaries we have are for locations. The only dictionaries we have are for words used in the area of indictments. So we find that, and then we go on, and we also find that we do the same thing. It's in the accused slot. And so therefore, we have now solved the anaphor problem in a very good way. Now, a very structured way. Just seeing how this is being done gives you the confidence. So if I'm pitching this to a person who is going to be using this in production, they're going to say, okay, I see, you have pretty high confidence of what you're doing. So now then I look in the knowledge base. If I looked at St. Louis resident, where before all I had was the location of St. Louis, and that was a resident. Now my function said, okay, now I can mark it as an anaphora or a pointing to Babatunde. And then if I look then in the sentence, in my bookkeeping of the sentences, his now becomes Babatunde. So now when we go and collect all this information, we go through sentence 1 and sentence 2, and we look at Babatunde, we can collect all that information just by going through the sentences. We don't have to do anything but collect what we found. And that's what we have. So here's Babatunde Taiwo. We find that he was, in fact, in an indictment charge. He lives in the city of St. Louis, Missouri. Missouri, again, was in paragraphs way below it, but I didn't show that, but it did pick that up. The gender is male, just from his role, and here are the crimes. So the input and output for the DOJ articles, here's the text in, and in this case, I put the output in XML, which, of course, in ECL is easy to deal with. How do you use the plugin? Well, this is, again, our very first pass at it. It will get even better. But this is our first shot at testing the alpha internal program for NLP, the NLP++ plugin. You can see up here, there's a record with free text. Let's say there's text here and there's text there, and it's got an ID. Well, we're going to pull in some real data into that record. That's what ECL does. And we got this other record. Now what we want to do is run 2 parsers on it. This is the full parse. This comes with, you can go to the GitHub and get this. It's a full English parser. We'll take anything you throw at it. And we have a demonstration corporate parser. So we're just using these as examples. And in ECL, of course, you can run this across record structures and take columns like, again, the free text here, run that, and put it into this second. And what will happen is this will call that NLP++ analyzer we just saw, and put that text in there, and voila, you have what you need. So let's talk a little bit about the NLP++ technology. The way I look at it, and I tell everybody, is think of NLP++ as a human reader. So if you have text in whatever domain you're looking at, or you have messy text. I'm a programmer. I use NLP++ for my programming at least a dozen times a year, because I, as a programmer, come across text that's messy, but I'm not going to write a parser for it. It's too hard. But I know NLP++, and if you know that, you can do these kinds of tasks. So think of it as whatever a human reader can do. OCR cleanup. We as humans can read that and clean up. Well, we've written very good NLP++ analyzer to do that. The way you think of it as it's a programming language to create text analyzers that normally require human readers. It allows for computers to do that to do what was considered impossible, and it creates new data and opens up new markets, which of course is very important, and works with any unstructured or messy data, as I have already said. The technology, when was it developed? It was developed in 1998, a $2 million startup. In 2001, it was launched right during NLP++ and VisualText, the IDE, right during the dot-com crash, which I turned to my fellow architect and I said, it's going to take 20 years before people catch up to it. Well, we're about 20 years in, so it's not a coincidence. So I guess I unfortunately was right about that, but fortunately we have it today. In 2013, it ran on the cloud for several years. It's called NLP Cloud on AWS. In 2018, the end of 2018, really, not very long ago, it became open source. And today we're working on the NLP plus plugin, the ECL plugin, the ECL plugin for NLP++, which adds powerful NLP to ECL. And we think that's going to really open up a lot of more programming opportunities, data opportunities for everyone. So the companies that have used NLP++ during the last 20 years, IBM of the UK, ETS, NASDAQ, Zio, Michael Page. And the architects of the system are myself and Amnon. We were both doing AI in the 1980s. I know we're aging, putting ourselves at our age. I'm in that group, but we started out in AI. We both met in the AI group in McDonnell Douglas in 1990, and we both moved over to TRW's AI group in Space Park in California. Interesting part of our working together, we participated in the DARPA MUC, or Message Understanding conferences, placing third nationally against, places like CMU, SRI, MIT, with only about 3 months of work. In fact, we were literally accused of cheating, but turns out that the next year, many of the techniques we used, people were starting to use. But that was sort of the precursor to NLP++. Amnon, in 1998, got funding to start up a company called Text Analysis International and lured me over to join him. And then in 2014, I came on board with LexisNexis because as an ECL programmer, and that was after reading about the ECL language, and I found very interesting parallels. And Amnon told me, LexisNexis and Elsevier are one of the biggest holders of text on the planet. And I thought, oh my gosh, this is super great. And this is what I saw. I saw big data. And when I was reading about ECL and the IDE and everything, I just immediately understood the idea because it was very similar to what I had developed with Amnon. And that you have ECL, which is its own language, powerful computing language for supercomputers, a great IDE for big data. Well, we had something similar. We had a powerful computing language for human language, and we had a visual text IDE for natural language. And most important, both of those compiled to C++. So some real-world applications running out there right now. We have a real-world application of processing real estate documents from 3 New Jersey and Florida counties as a prototype out there, but running in the real world, versus a company like CoreLogic, which is a billion-dollar company, which uses human readers who are located in India, Barbados, and the Philippines, and they read all day long. Well, our processor, which can mimic the knowledge of a human reader, is running with NLP++ with no human intervention is out there, and these counties are actually using them. Also, NLP++ for the same task is doing post-OCR, which has really high yields and the highest quality of text, image-to-text conversions, because we can build an NLP++ analyzer to look at the text like a human does and make all those corrections and encode that knowledge into NLP++. Other applications NASDAQ ran this as a sentiment analyzer for social media news. They chose NLP++. It was literally the 100th technology they had looked at in the NLP world. And they threw everything out because when they tried to use it, they could not break it technically or conceptually. All of the things, all the commercial products, all of the NLP toolkits, which I'll show you a little bit later how and talk about them, couldn't break it. They literally flew out to California to meet myself and say, what did you guys produce? Why is it so, why can't we break that? And they used it, loved it, and it ran for numbers of years. We also have done OCR historical literature with relating to ships back to documents from the 1700s. You can imagine that's not an easy task for people who read them today. And that was actually done on the NLP cloud. Also, we've done medical device problems, problem reports, extracting information. Again, that was done on the cloud. The DOE, the Department of Energy, is interested in the technology for looking at building permits to see if people are thinking about solar. It's just there's not a checkbox there. You have to look at lots of things. To write a program to go through that and do that is impossible, but it's not with NLP++, and there are many other examples. So how does NLP++ stand up? Because it's open source. Why would you, listening to me from the HPCC Architecture group, why are we spending the time to do this? Well, if you compare this with the best free NLP tools out there, there's an allure to that. And a lot of people go through this. We've seen this over and over. We have clients tell us this. So NLP Toolkit allure, they're free, they're simple to install, there's no programming needed, they're out of the box. You can get parts of speech tagging, you can get entity recognition, co-references, dependencies, sentiment, and it can handle anything you throw at it. You're going like, this is great, I don't need to program anything, NLP is solved. Well, that's not exactly what happens. You can talk to a lot of companies that do this. We'll try that. NLP Toolkit problems. Well, NLP toolkits are really black boxes that really can't be modified internally. You can do some have a few, you can add dictionaries, you can change some things, but pretty much it's what you get. And the reason they fail often, and it took me a while to figure this out, for this talk, I really thought about it. The real reason they fail so often is because they try to do everything. And if you try to do everything, you're going to fail, especially with any language. And what happens is the people who try to use them, they cannot, these parsers, these processors cannot be fixed or enhanced to perform the desired task. In fact, when I ran that same article with Core NLP, which I did online, I looked at it and says, okay, it's failing on these 4 things. What do I do? And there was really not much I really could do. I was really stuck with what they had. And then I have to write some post processor. And by that time, I could just write an NLP++ processor that does exactly what I want. So again, the reality of NLP toolkits it's downloaded a lot. Very true. You can look at them. Rarely used. We talked to, over the last 20 years, we've talked to real clients. Doesn't do what they wanted. That was the number one thing. When they didn't do what they wanted, it was too hard or impossible to modify, and they were quickly abandoned. And so NLP, the biggest difference, it's not a toolkit. That's it. NLP++ is a computer language. It's 100% black box. You can construct, analyze to do the desired task in the most efficient and intuitive manner. It does come with a part of speech tagging and syntax tree that's 100% accessible. If you can use TAI parse out of the box. And if it's not getting this date phrase, because we didn't do it, we have a pretty good date phrase parser, it's only in English, and it doesn't get one, you can go in there and add your rule. You can tweak it. It's yours. Fork it off. Go for it. And of course, NLP++ was chosen over 100 other toolkits and products, commercial products as well, because commercial products have the same problem. They're black boxes. They're expensive. You spend $30,000 a month on it. You can't change it. When you ask them to change it, they're going to charge you a ridiculous amount to change it. You can write it on your own. So let's take a look at, and we'll get a little bit more technical here. We're going to look at the ECL patterns and rules versus NLP++ plugin. ECL patterns and rules, they are great for local patterns in unstructured text. You have phone numbers, things with cleanups with addresses, use it. You don't need the whole NLP++ plugin for your ECL. But NLP++ is great for all levels of NLP in unstructured text. ECL patterns and rules. If you are a linguist, you know Noam Chomsky. A lot of people know him for his politics, but he is actually the father of modern linguistics. He has these grammars, and Chomsky has a type 2 grammar. A type 0 is a Turing machine, and that's what I would classify the patterns and rules in ECL today. NLP++ is a type 0 grammar. It's a Turing machine. You can give enough space and in the universe, you can write anything. Supposedly, that's what a Turing machine is. ECL patterns, there's no specific ID for helping develop those patterns and rules. So as you're doing them, you can get outputs, but you don't have any really a visualization of that. You have, of course, with NLP++, VisualText IDE, which greatly speeds up analyzing and development. In ECL, you really don't have a syntactic tree. You have that in NLP++. There's really no bookkeeping device. You have that, of course, with NLP++ conceptual grammar. And there are the NLP currently with ECL, which again is very useful. There's only a couple functions out of the hundreds of functions ECL. And of course, NLP++ is a fully dedicated computer language for natural language processing. In fact, it's the only one. If you look it up, what's the best programming language for NLP? Anybody know? Unfortunately, this is not an audience. I'll get the answer: Python. And when they say that, I bite my fist. I said, there's a better one out there. Let's take a look at machine learning NLP versus NLP++. Machine learning is great at finding patterns in immense amounts of data. NLP++ is great at reading text and performing a specific task. NLP machine learning as training set needs to be pretty large to develop. NLP++, if you're a human being, you get about 20 articles. You can do quite a lot with that because we have knowledge of language and we know what we can do with that. Training with little or no coding. Of course, NLP++ is 100% coded, but again, it's 100% transparent. If I leave this analyzer, somebody else picks it up, they can look at it and improve it. You can't do that with any other kind of system. So corrections are made by finding similar text and rerunning the algorithm. It's not guaranteed to solve the problem in NLP++. What's really great over human beings, we can look at the article that failed. We can find it. Is it a pattern we don't have? We don't have missing something in the dictionary. Is it a phrasing we don't have? A new phrasing of an indictment we didn't know. Oh, these are the new way a title is, new titles, that kind of stuff. So we know how to fix it. When we fix it, we know it's going to be fixed. We're not going to guess that. Is it going to handle 6 others? We've put a new knowledge base entry for an indictment phrasing. Any indictment phrasing like that in the future, no matter how it's done, we're going to pick it up. So, so not great at extraction, machine learning. NLP++ is very good. And of course, NLP machine learning, it does what humans cannot, which no human can go through gajillions amount of text and find patterns. But NLP++ does what human can do, but right now computers cannot. But with NLP++ they can. So conclusion is really looking at NLP++ versus the ECL rules and patterns. Again, summarizing, ECL, NLP pattern matching are great for rule-based local pattern matching in unstructured data. And NLP++ is great for automating more complex human reading tasks. It provides a framework for all the tedious bookkeeping needed in NLP, leaving the programmer to concentrate on solving the problem. I will say a little bit about that. One of the things when people or programmers are thrown the task who are not NLP or natural language processing people, they're thrown a task, hey, take this data and try to get this information out. The first thing you have to do is think, well, what am I going to use? If you use the toolkits, then you get all this stuff that's not working. But if I had to do it my own, how would you do it? Well, you'd have to have some type of mechanism or toolkit. With NLP++, and VisualText, you can sit down and do that and start playing with it and building it right away. And it allows you to concentrate on how you do it, not anything more. So also NLP++ allows for writing NLP++ analyze to perform specific tasks up until now that have been deemed impossible. And of course, it's 100% computer code, robust, maintainable, and extensible. Application areas, you can see all these: history, government, legacy, real estate, healthcare, science, legal, news, finance, social media, and also does high accuracy OCR. Now you can take the plugin, take this text, make it into structured data, of course, open up new revenue streams and the like. And right now, the way I would sum this up is your NLP++ ECL plugin allows you to add automated human reading to ECL. So you have HPCC, data-rich unstructured text, and with NLP++ called from ECL, now you have new and rich structured data. How do you develop it? Well, you don't develop it in ECL. You develop that offline by building your analyzer with a VisualText IDE on the Windows platform right now, runs interpreted or compiled. And in the future, I really think it's going to be coming out this year, because I'm making great progress on is the NLP extension for, I call it NLP++, but NLP extension for VS Code. And then once you got that, then you can call that from within ECL. Here's the IDE. Basically, what you have are NLP++ files, programming files, language files that are executed in a row or a sequence. You can click on that and you see what highlighted in the text. Here you have a rule editor that's very nice. You have an inspector of the knowledge base. You can see and inspect the attributes you're building, and of course the syntax tree. And the timeline for the NLP++ plugin is we're currently in alpha internal at LexisNexis, and soon to be released version 1 to the public. Future would be an NLP++ bundle where you could import, for instance, data directly from ECL into NLP++, like dictionaries and things like that could be used in the knowledge base to do those human reading tasks. So thank you very much. My name is David D. Hilster. Here's my email. I'll be glad to help you no matter where you are. I'm working on the open source project myself and Amnon. But you'll be glad to help you with building any NLP++ analyzer if you have any questions. Thank you.
Thank you, David. I'm looking forward to that plugin. I had one quick question, just to do with the development flow. Do you envisage that the developers of the knowledge base will be domain experts, if you like, and they will wrap up their knowledge base in a way that it can be easily called from ECL, the ECL plugin?
Oh yeah, absolutely. That's one of the things that it's really what you're really doing. When you read text, what a person does, it's really nice to read it and understand it. But each one of us has the world model in our head. Well, when we look at data or we look at an article like that, it's got all kinds of information. Indictments aren't the only thing that happen in there. So what we have to do as a designer is to say, okay, what knowledge do we want out of that? And that knowledge base could then easily be done, easily taken from NLP++ and put into the format. We can put it in any format at that point. It could be even put into a format that would already be in a format that could be ready for you to use in ECL. Right now in the alpha version, we're just passing back a string because we're just testing the whole concept here. But in the future, the knowledge base not only could be there ready, but it could be ready in an ECL format, used by analyzers, brought in and used by analyzers in knowledge bases that everyone could use in a certain area, and then also then be produced. So we can use the knowledge, we can produce new knowledge that can then be used by analysts, et cetera, to enrich the data that they have from the free text.
Okay, very good. All right, we're going to wrap up now. It looks like we have about 20 minutes until our next breakout session start. Just a quick recap. Coming up, we have on the data lake thread, we have a COVID-19 data lake presentation. On the machine learning thread, we have managing data pipelines. On the cloud thread, we have leveraging and evaluating Kubernetes support on the Microsoft Azure cloud framework. And finally, back in this room, we have coming up using the HPCC Systems general.
I'm not sure if people are hearing him, but is he back? Hello, Gordon? Yes, I think Gordon was giving us a overview of what's coming up in the other sessions. So you want to take a look at those. We have numerous breakout sessions. And of course, if you miss this one or you miss another breakout session, we do have recordings. So you may want to check those out. I'm sure during the conference, a lot of people are going to want to go to several of them. But if you can't, you'll be able to see this and other talks in the breakout sessions, the recordings of those.
Okay, David, thank you for taking over there.
No problem. This is the way the new world we live in.
All right, guys. Thank you.
Thank you.